Section 2.7, Video 1, Verifying Logic Arguments. In this video, we will cover the objective of using truth tables to determine the validity of arguments. In logic theory, an argument is a series of statements called premises that lead to a conclusion. We're going to use a truth table to determine whether an argument is valid or invalid. Here's the first argument we're going to work with. If it is Friday, then Eric watches a movie. It is Friday. Therefore, Eric watches a movie. Sometimes it's helpful to write an argument in a vertical fashion, similar to how you might have written it in an arithmetic problem. Above the horizontal line are the premise statements, and below the horizontal line is the conclusion. It's going to be helpful to us to also convert our written argument into symbolic notation. Using the statement P and Q as shown, the first premise statement, if it is Friday, then Eric watches a movie, is a conditional, and we would write that as if P, then Q, or in symbolic notation, P is arrowing towards statement Q. The second premise statement, it is Friday, is restating statement P. Below the horizontal line is the word therefore. For mathematicians, a lot of times they use the symbolic notation of 3 dots in a triangle form for the word therefore. And then writing the statement Eric watches a movie would be restating statement Q. So we have 2 premise statements above the horizontal line. That is given information. If we are given premise 1 and premise 2, we want to determine whether the conclusion makes the argument valid. Let's get started. We have the same argument we were just working with the same symbolic notation. We're going to use 2 different methods to show whether this argument is valid or invalid. The first one is method 1, and we would convert this whole argument into an if-then statement. We were just saying, if we were given premise statement 1 and premise statement 2, then we want to determine if the conclusion makes the argument valid. That's how we convert this whole argument into one conditional. If we have premise 1 and premise 2, here's our antecedent, if, then we want to determine if the conclusion makes the argument valid. So we're creating an if-then conditional with the premise statements as the antecedent, connected with an and. Premise 1 and premise 2 are given. Then we want to determine if the conclusion makes the argument valid. To begin putting this into a truth table, we're going to start with our innermost parenthesis, if P, then Q. In our truth table, I already have our statement P and statement Q written. As we've been doing throughout this whole unit, P would be true, true, false, false, and statement Q, true, false, just to be consistent from problem to problem. Remember that the direction of the arrow is important. For this particular problem, if P, then Q, P is the antecedent and Q is the consequence. So true implies true would be true. True implies false is the one conditional that gives us a false result. False implies true would be true, and false implies false would also be true. The next part we're going to work on is connecting that if-then conditional with statement P using an and. I'm going to go ahead and write statement P here and just rewrite the truth values. And we're going to connect these two with an and. True and true gives us a true. The next case, false and true, would be false. The third case, true and false, would be false. And the last case, true and false, would be false. Until now, we've been able to complete this entire bracket set, which is the antecedent of our whole argument. Now we're going to write statement Q. And repeating statement Q would alternate true, false, true, false. The next and final column that we need is our whole argument. And our whole argument is the large conditional with our two premise statements as the antecedent connected with and, our conjunction, then the conclusion, in this case is statement Q. Let me connect our two premise statements with the and see if that implies our conclusion statement Q. Notice that we have here, we're connecting this column and this column with our if-then. Here's our antecedent column, and here's our conclusion column. And so you can see the direction of the implication. In the first case, we have a true antecedent and a true conclusion, and that gives us a true truth value. The second one, false implies false, is also true. False implies true is also true, and false implies false is true. In the end, when our truth table is complete and we have our final truth value column, we're looking to see if all the truth values are true. And that does happen in this case. That tells us that the argument is valid. How do we know if it's valid? We know it's valid because we created a truth table using the entire argument, and at the end, the last column of all the truth values was true. Let's go ahead and try method 2. In method 2, I want to remind us that when we're working with conditionals, if-then statements, the one that fails is when we had a true antecedent and we implied and then our consequence was false. In that case, the result is false. In all other cases, the result is true. And one last one, false implies false, also a true result. What we're trying to avoid is getting a false, because remember that if we end up with all final truth values true, then we know the argument is valid. So if we can prove that we do not have this case, then we know our argument is valid because it must be one of these other three that end in a true truth value. That's the basis of method 2. So to work with method 2, we're wanting to show that if you start with a true antecedent, which is our premise statements, then the conclusion, the consequent, is also true. Because the one that ends in a false result is a true antecedent with a false conclusion. Let's take a look at our premise statements. Again, we're trying to think of if our premise statements are given, then our consequent will tell us whether our argument is valid or invalid. So let's take a look at premise statement 1. And then we're also going to take a look at premise statement 2. In this case, premise statement 1 is a conditional. If P, then Q. Remember that the direction is important. In this case, P is our if portion, our antecedent, and Q is our then portion, the consequent. So true implies true, true implies false, false implies true, and false implies false. The only case that ended with a false truth value was when we had the true for the antecedent and false for the consequent. Next, we're going to look at premise 2, which in this question is just statement P. And repeating those truth values, we would have true, true, false, false. The last thing we're going to look at for method 2 is the conclusion. In this particular question, the conclusion is just statement Q, so I'm going to repeat those truth values. Now what we're looking for, going back, is we're looking to make sure that when our antecedent was true, our conclusion was also true. Our antecedent is the entire premise section. So in this case, we have two premise statements. We want to look for cases where both premise statements are true. That happens here in case 1. Our two premise statements were true. And that doesn't happen in any other case. The next thing we want to look for is when our premise statements are true, we want to ensure that the conclusion is also true. And that does happen here. So, is the argument valid? Yes, it's valid. How do we know it's valid? We know it's valid because when we found the truth values of each premise statement and the conclusion statement, when the premise statements were true, the conclusion was also true. Let's try another argument and use both cases. Okay? The second argument, if Caden is watching The Office, then he laughs. And then the second premise statement says Caden laughs. We want to determine if the conclusion, therefore, Caden is watching The Office, makes the argument valid or invalid. Using statement P as Caden's watching The Office and statement Q as Caden laughs, our first premise statement would be if P, then Q. The second premise statement is Caden laughs, which would be confirming statement Q. Remember, above the horizontal line are our premise statements or given information. Below the horizontal line, we have therefore, Caden is watching The Office, would be statement P. Using the first method, we're going to take this entire argument and write it as a conditional. If we have given information, premise 1 and premise 2, then does the conclusion make the argument valid? So to write this as one large conditional, we would say if premise 1 and premise 2, so here's premise 1 and premise 2, are given, then does our conclusion, statement P, make the argument valid or invalid? To begin our truth table, we're going to start with the innermost parentheses of our antecedent, and that would be the conditional if P, then Q. Remember that the direction of the conditional makes a difference, and the one that ends up with a false truth value is when you have a true antecedent and a false conclusion. The other cases have a true truth value. The second part of our antecedent is just statement Q, and that would be true, false, just repeating it. And we're going to connect those two columns with the word and. So connecting them, P implies Q and Q. Remember that true and true is true, and you need to have both of them true. False and false would be false. True and true is another true, and true and false is false. Now we've finished this entire bracket section of the antecedent. Now let's work on the consequent, statement P. Rewriting that, it would be 2 trues and 2 falses. Now we can write the whole argument. And the whole argument would be, if P, then Q, and statement Q are given, then does the consequent statement P make the argument valid or invalid? We're taking this column as the antecedent and this column as the consequent. So the direction of the arrow is important. And true implies true is true. The second case is also true. The third case gives us a false truth value, and the last case gives us a true truth value. Notice that when we're done finding the truth value of the entire argument, we did not end up with all trues. We ended up with at least one false. That is what makes our argument invalid. And how do we know? We know it's invalid because when we found the truth values for the whole argument, they were not all true. Let's go ahead and take a look at method 2 with that same argument. Using the same symbolic notation, if Caden is watching The Office, then he laughs, and confirming Caden laughs, statement Q, therefore, does the conclusion, Caden is watching The Office, make the argument valid or invalid? For method 2, as a reminder, we're looking to ensure that when we have the premise statements given, that they're true, and that the conclusion is also true. Let's take a look at writing premise statement 1 in our truth table. Premise statement 1 is just the first premise given. If Caden's watching The Office, then he laughs. The one case that fails, gives us a false truth value, is when true implies false. All of the rest of them give us a true truth value. Let's go ahead and write the second premise statement, which in this question is just statement Q. Q is true, false, true, false. The conclusion is the last part of method 2, and in this case it's just statement P and rewriting those truth values, true, true, false, false. What we're looking for in method 2 is where we have both premise statements true and then looking to ensure that the conclusion is also true. And that's okay in case 1. We also have case 3 with both premise statements true, but notice in this case the conclusion is not true. And so this is the one that makes our argument invalid. And how do we know? We know our argument is invalid because whenever we found the truth values of the premise statements and conclusion, when the premise statements were true, not all of our conclusions were true. So this is going to give us a false truth value, which indicates an invalid argument. And that ends example 2.